Okay, so that panel represents a lot of work. Took a lot to do it. I did wire it and build the whole thing myself. It's not a pre-ordered panel or anything like that. Honestly, it's worth the time, saves a lot of money to do it that way versus hiring somebody to do it. But it is quite an endeavor to get it all done. So basically this started as a factory panel. I'll show a picture like what it looked like. I just started taping up some paper things to see what I wanted to do with it. So I drew this panel up in CAD, got the curves right and everything like that, and started dropping in units and got it designed. And so my goal with this unit was to be able to do all my avionics maintenance sitting in the seat and reaching through the panel. There's a lot of airplanes you have to lay underneath to do a lot of stuff. My goal is to not have to do that in this airplane. So each individual unit of this panel is removable. So the big Garmin screen comes out, the switch panel comes out individually, the breaker panel comes out individually, and then that allows you to sit in the seat and reach through and work on stuff with full access to everything. All right, so I'm gonna interrupt this video for just a second. So some of you guys have asked, how do we fund this? How do we do this? Who is MA Global? So my wife and I started MA Global. That's our organization that we fund this airplane building through. The purpose for that is that we're gonna build this airplane, then it's gonna go to Africa, and my wife and I will be using it for all kinds of stuff there to help the people of the country of Niger out. So that's the really, really short version. But basically, we're partnered through churches and individuals and fundraiser events here in the States to make all this work possible. Our biggest event of the year is coming up, and it's one of our awesome partners called Man Day. So Man Day is basically, it's the best day of the year. We race cars, shoot guns, ride bulls. There's airplanes, there's, all kinds of stuff. Like literally, it's fantastic. So I'm gonna throw a video up. It's kind of like a little promo so you guys can see what it is. If you guys are in central United States, this event is in Plevna, Kansas on April 29th of this year. So that's a week from the day that this video comes out, basically. So April 29th, 2023, if you guys want to come out to this event, I'd love to meet you guys. You guys can hear the story, and man, it's literally the best day of the year. It's probably, it is a fundraiser, like it helps us be able to do this thing, but honestly, it's the best day of the year. It's so fun. So if you're a guy, get you a ticket. If you're a lady, buy your man a ticket. Pretty simple. So basically I drew out this panel, and then I drew out these individual units that go in each section. I'll show kind of how those turned out. Then I had to have a buddy that has a CNC shop, and so we CNC'd out all these things and then started putting everything together. So you'll see on the panel, there's right now it's like a black carbon fiber look to the each of the individual sections, and there's some temporary labels. My end goal here is I'm gonna fly it a little bit and make sure everything's how I like it. I don't need extra breakers or anything like that. Once we've flown it a little bit and I like it, and we're done messing with it, I'm gonna have some final ones cut, and then I'm having them laser etched and everything to make it look official. But I don't want to laser etch them and then have a stick-on label for one thing that I decide to add or something like that. So we're gonna fly it for a little bit, and then I'll get the nice laser etched ones cut. First, I'm gonna go through the inside, and I'm gonna show you what that looks like. Go through each individual unit, and then we're going to show you behind the panel. Behind the panel is busy. There's a lot of stuff going on, and it was tight to make it all fit, but we got it all to fit. It all fits in there just fine. So I'm gonna show you how I did that, and then we'll see what you guys think. Okay, so our panel here is all powered up, and we can see everything. Right here on this side is our engine switch panel. So this is our key, which is our master turn on, ELT, emergency power switch for all the electronics that we need to keep the engine running. These are our 3 dimmer switches. That's a carbon monoxide press to test. And then we've got these 9 switches right here, and these are all engine and fuel switches. So right here you've got a fuel pump mode switch. This pump switches between fuel pump 1 and fuel pump 2. This turns your left fuel tank off. This turns your right fuel tank off. Right here we have an alternator switch, and up is alternator 1. Right there is both alternators off, and that is alternator 2. So you can't turn them both on at the same time, but you've got 2 alternators there ready for you. This is a start power switch. So right there lets you start with 2 batteries because we've got dual batteries. Right there's battery 1, and all the way down is battery 2. So most of the time you're going to start on battery 2 because Avionics are pulling power from battery 1. But if it's really cold or you got low batteries, you can flick it up and that gives you 1200 cranking amps of power out of the earth axis. And then right here is the start switch. You're going to push that down and that's going to engage the starter. And then basically these 3 switches right here are your run-up switches. So this is ECU 1. When you flick that on, you're going to see the ECU 1 light up blue, and that's off. Same deal here, ECU 2. It's going to light up green and tell you that it's on. And red means it's off. So right here is your injection control. So right now, ECU 1 is running injection. That's why it was blue. If I swap this, then ECU 2 is going to pop up as blue. So if we have both ECUs on, right now we can see that both ECUs are on and operating. ECU 2 is controlling injection. Now ECU 1 is controlling injection. So on run up, you're basically going to do a mag drop, essentially, on your electronic ignition on these 2. And then you're going to flip-flop your fuel injection between 1 and 2 to make sure that both of them are able to take over. So next we got this Garmin G3X screen. This is one of the 10-inch Garmin's. Fantastic setup. You know, you can do split screen mode and everything, engine monitor, whatever you want to do. You know, change all your parameters, you get your message center, all that kind of stuff. There's plenty of videos out there on Garmin's G3X, so I don't feel like I need to cover that too much. Here in the center we've got a stack. So this is a G5, and then we've got your Fly EFII head controller. So these are on, if you see these screws coming down the side, essentially this is its own stack like I showed you in the construction part of this video. And so if at any point, well, we want to change this needs to be changed, anything like that, you literally pull 6 screws, have a new piece cut, and you can put whatever you wanted to put in there. In the center we've got a GMA 245 intercom, Garmin GTN 650 XI. This is the Garmin autopilot head. So here on the bottom we've got a hardwire PDM keypad. So this keypad is a 12-button keypad that can be programmed through that PDM box that's in the back. And here, when we go through the brains behind, I'll show you what that looks like. But essentially this can run 25 of its own circuits. It can take sensors, it can take all kinds of stuff. So really cool unit. If you guys are interested in one of those, I'll link their website. But essentially you click on this button right here, and that is going to kick on all kinds of stuff. So it's going to kick on autopilot, my other screen, all that kind of stuff. So right there you got your nav lights coming on, then you got your strobes coming on, and then right here you got wig wag on your landing lights. If you click it one more time it goes solid, and then if you click it again it goes off. And then right here you've got your cowl flaps. If you click it once, now my lower flaps are open, you've got a yellow indication. If I click it again, now all 4 flaps are open. I've got a green indication, and then right here is pitot heat. So essentially, I like my airplanes in a flow. So on this left side, all my switches need to be up for takeoff. And then I come over here, this entire top row needs to be green if I'm IFR. If I'm not IFR, this last one can stay off if you don't want pitot heat. So that just is a really good way to self-check yourself every time you take off. Right here is left fuel transfer, right fuel transfer. I have a belly tank as well. That's a belly transfer. Then we come to right here, and that's going to be my heater. And that is going to open, run some linear actuators on some valves down here that lets my heat into the cabin. And then right here is cabin lights. Click that, turns green, and it's going to kick on my cabin lights in the back of the airplane. And then right here is my dimmer. So when I click this, you're going to see the keypad dim. And then it's going to kick on a post light over here, a post light here, and then it's also going to kick on post lights on the fuel gauges. So we got a post light on this fuel gauge and a post light on this fuel gauge, and those run off of these dimmer knobs. So I can brighten those and I can bring them back down as well, and I can even shut them off individually. So that lets that. This dimmer right here runs the panel lights. You can dim those post lights as needed. And then this first dimmer right here is gonna dim this this AOA as well as the button backlighting on the panel. So moving on over, we've got our passenger warning. You gotta have those in experimentals. Then we've got our G3X. This is the smaller unit. So this one's functioning as a multi-function display, but it can also be a PFD. So if I've got somebody flying from the right seat, they've got their own screen. Most of the time I'm gonna have it open to an engine monitor. But you know, you can check all kinds of stuff. You've got your GPS, traffic, terrain, weather, you know, charts, anything you want to do, you can do over here. Most of the time it'll be on engine monitor. So this is the breaker panel. Essentially, this is my essential bus that is engine electronics and IFR avionics, and then at the top is the rest of the avionics that run on their own bus. That way you can load shed as needed and check individual avionics with ease. That's basically it. It's just a basic breaker panel, nothing fancy. This side, this right here is just a dual USB charging center. Right here we've got an aux jack in, and you can see that I've got a cord plugged in there. That just plugs into your GoPro and gives in-flight audio rather than having to run those little tag units. I'll post a picture of them that go in the headsets. I've got a Limo plug set up, so this just lets you plug right into the GoPro that's sitting right here or whatever and gives you audio. This is going to be your park brake, and then this is your alternate air if you were to clog up the air filter. So that's the basics of the panel right here. The last thing is a AOA indicator. Once we get that calculated in flight, that'll be indicating as well. That's just another awesome little unit from Garmin. And then the only other controls here are your throttle control and your prop control. And as you see, there's no mixture. That's because that's run by the EFII. And then right here, this little knob, you can trim your fuel as needed. Once you get it all calibrated, you really shouldn't need that too much. So that's the panel. It's been an interesting build. I think it turned out really well. It's pretty light for what it is, but it's fully capable. It's a fantastic panel. You couldn't ask for any better avionics to go fly IFR. It was probably way overkill for VFR stuff, but for IFR flying, this is about as good as it gets. It runs a 3-axis autopilot with yaw damp, and it's got auto trim and all that kind of fun stuff. So pretty good unit. I'm excited for it. Let me know what you guys think. Okay, so before I cover up this boot cowl right here and cover up all the avionics, thought I'd give you guys a quick rundown on kind of how I did everything. So behind the panel here, you can see there's a big platform. So this platform is a piece of 1/8" honeycomb carbon fiber plate stuff. So basically I made that. I'll show a picture of what it looks like before I put anything in here. But basically that just gives you a good flat platform all the way across here to be able to put stuff. So this airplane ended up having a lot of electronics in it, and so most guys just kind of, you know, stick them to the tubing in here and kind of, you know, place them different places, but I had too much to be able to do that. So I built this platform for it, and then I started putting stuff in where it would fit, and it's tight, but we got it to all fit. So right here on this side, we'll start with this. This is the bus manager, so this is part of the EFII system as well. Basically this system right here controls the power distribution of the airplane. So it basically gives a triple redundant power source for the electronic ignition computers as well as the injectors. So that's important when you're doing the electronic ignition. If you don't have power to it, the engine shuts off. So it can be super reliable, even more reliable than mags, being that there's no mechanical things involved in it. But you have to have a good power source. So this bus automatically has one redundancy backup where it's got a main bus and a secondary bus. The main bus, in the event of a power failure on your essential bus, automatically backs that up. So you've got a backup right there. So you have to lose those two buses, and then you've got a switch on the panel over here. And that switch basically links the batteries directly into the electronic system right here. So it's a good, safe way of doing that. Right here, we've got the Garmin GEA24. That is your engine monitor. Also gives you some discrete inputs and a couple other things. Under here, I've got an electronic carbon monoxide detector that ties into the system. Right here, we've got two shunts, one for the primary alternator, one for the secondary alternator. That way you've got an entirely redundant system on both sides. You're not running through one shunt. You can run through one shunt, but then if the shunt goes bad, you lose all your alternators. So went ahead and threw two shunts in. This is the back of that big screen up front. And then right here, you've got the two EFII computers. So those run all the injection, ignition, all that kind of stuff. This is a GI 260 angle of attack indicator. It'll go right up here once we have the boot cowl on. That's the back of the G5 and the back of the EFII system right there. Then we've got our center stack right here, and how I did this is basically I ran some legs off of the 650 down to the platform there, and then that platform is actually bolted to this cross tube under those wires and over here as well. So tucked down in here really, really tight, you can see a little box. That box is what's called a PDM-25 by Hardwire Electronics. It's a programmable solid-state circuit breaker system. So that one has 24 individual circuits as well as sensor inputs and all kinds of stuff. So basically you run all your wires to it, you hook a laptop up to it, you program everything you want, multifunction buttons and everything that run off of that keypad that's on the panel. And it basically is just a super lightweight alternative to doing breakers, and I didn't have enough room to run all the breakers that I needed in this airplane. So we ran all that on that. There's nothing that is IFR required or anything that pertains to engine running that runs through that box. That is all non-essential airframe circuits. So that's, that's everything from your linear actuators to turn on your heater, to your wingtip lights, nav lights, cabin lights, dimmers, all that kind of landing lights, all that kind of stuff. That all runs through that PDM, and it's a really, really good way to do it. Highly recommend it. Super impressed with that. So that's that box right there. Right here we've got 245. We've got a 650, and then tucked down in here you can see a little black box. That is a Garmin GDL 51R. So that Garmin system basically gives me my ADS-B in because I ran the cheaper transponders. It's about $1,000 cheaper to go this way to buy that box and the GTX 35R, which I'll show you on the other side. But basically this gives me ADS-B in as well as Sirius XM and another GPS source as well. So this airplane actually has like 5 GPS sources in it. I hooked antennas to almost all of them just so you've got redundancy and all that good stuff, but you don't necessarily have to have that many antennas. So the only other thing on this side is you'll see these 2 pass-throughs. These are firewall pass-throughs for the EFII system. And then there is an Avionics ground bus tucked right down in here. And that's one ground bus, there's one on the other. And these ground buses are tied directly to my central ground point that's right here. So this whole system in this airplane is centrally grounded to one point. That's the best way to do it in any airplane that has any amount of electronics. Nothing is airframe grounded. So every one of my lights has a return to ground. Every device has a return to ground. Nothing is grounded in any of the wings anywhere. Nothing's grounded to the frame or anything like that. So you've got one central ground location, it's the best way to do it. So
whenever I'm about to do something, I think, would an idiot do that? And if they would, I do not do that thing.
Over here on this side, we've got a GAD29. This is the interface for the G3X into the 650. So if you have even a dynon screen or anything like that, you'll have to have one of these boxes to be able to interface with the Garmin GPS systems. Right here we got the GAD27. That lets me run some different airframe stuff, some discrete inputs, as well as several other things. This right here is just a bank of relays. So these all run my linear actuators. So I have linear actuators on the cowling for the cowl flaps, as well as linear actuators on the heater. The one on the heater, it's lighter and easier to do the little bitty linear actuators than it is to run cables. So basically what these are is they're double pole, double throw, normally closed relays. So what it lets you do is that they run off of the power or the essential relays. So the relays that run the cowl flaps, if you were to have any kind of a power failure, you want those to open. It's better for them to be open than them to be closed. So if there is a power failure in the airplane, they automatically go back to open. So that's what these relays do. But you have to have some kind of way to switch your poles, because on a linear actuator, you have a red wire and a black wire, or power and a ground, and you swap those. You swap your ground to power and power to ground if you want to reverse the linear actuator. So you have to figure out some way to do that. You can do it with a mechanical switch, but I wanted to run it through my PDM. And so there's no way to actually do that. So that's why we're running these relays right here. Gives you a little bit of redundancy, also having backups. And they're all the same relay, so if for some reason you had one go out, you could swap while you're waiting for parts to come in. So that's that. Right here we've got our 2 BNC, forget what model these are, LR3Ds. These are the 2 voltage regulators. Got one for alternator 1, one for alternator 2. They are the same voltage regulator, so if you had one of these go out, you've got 2 of them. You can swap back and forth if you run on primary or whatever. But again, we've got 2 fully redundant systems. So that includes 2 fully redundant voltage regulators. So right here, we've got a fuel pump relay. This is run by the bus manager. Basically what this relay does is that if it ever senses a fuel pressure drop when there shouldn't be a fuel pressure drop, it automatically kicks in the backup fuel pump. And that system as well has a manual override so that if it does fail, you have another way to kick on the secondary fuel pump, because in this system, it's a constant flow. You're always pumping fuel. So that's that. Right here's the back of our other G3X, and that is about it. So there's a lot of stuff tucked up in here. It's really tight, but it does all fit. This is a good way to do it. The way the panel's built is you can reach in and maintain all of this just sitting in the seats. So none of this stuff actually has to come apart. You don't have to pull the boot cowl or anything unless you're doing major maintenance. But the boot cowl is made in a way that if you were doing an Avionics upgrade for some reason, or you needed to change a big part of the system, you can just pull that boot cowl off and get in there. So this is all here. The only two things I did tuck down on the side is this is a GTR 20, which is the remote comm for the G3X. And this is a GTX 35R. So this is a remote transponder that's mounted down here on the side. So those two are mounted down there on the side. Really should be no reason to get to them unless you need to service them. If you do, basically this boot cowl just lays open and you can get into to service those. So that's the brains of the operation behind the panel. There's a lot to it. Garmin's fantastic. Wiring is a little bit of a task, but it's nothing, you know, it's no more than the Dynon in all reality. And so great system. It's really cool because it's all just different boxes. Run your CAN bus and then your other stuff. And highly recommend Stein Air if you guys need wiring diagrams. They do a fantastic job. So that's the brains of the operation. That's what makes all the panel work. If you guys like it, let me know below. Let me know what you do different, or if you guys have any questions, leave them below. And we'll see you in the next one. Bye.